guys, welcome to my channel.
This is the polished surface on the back side of it, and this is the convex mirror. This is the polished surface and the back side of it on the right side. Okay, so there is a relation between the radius of curvature and focal length. You know this I told you in the earlier classes. For example, okay, there is a I found the space. If this is the focus, the double of this distance is the center of curvature. You remember this or not? Because we've done all the cases of concave and convex mirror, right? So if this is 5 centimeter, this also has to be this center talking about, okay? This has to be 5 centimeter only. It means from the center to this curve, this is called radius of curvature, and this is the pole, and this distance between the pole and focus is given by this cursive f called a focal length. This is called focal length. Okay, this is small f called focal length. So basically focal length is okay, sorry, it's half of the radius of curvature. So if that distance is r, for example, this r is 10 centimeter, the focal length has to be 5 centimeter only. Okay, so the focal length of a spherical mirror is equal to half of its radius of curvature. So f is equal to r by 2. So in this case, on the left hand side, what I can see, f is equal to, for example, this r is 10. So 10 by 2 equal to 5 centimeter is the focal length. Then with this, no issues in this, right? Easy, because we done this earlier. The same thing is coming up in the form of like how can we write this? Okay, so this is the example from the left hand side. Now, what is the mirror formula? Now, one formula we all have to remember from today, that is the relationship between the image distance,
Guys,
object distance and the focal
ये मैंने
length.
आज स्टार्टिंग करी है बेड वॉर्ड्स की.
1 upon f equal to
मैं
1
पहले
upon v
खेलता
plus
था
1
पर
upon
मैंने डिलीट कर दिया.
this f equal to focal length.
7.73 मेरी.
This v is equals to image distance from the pole, okay, and v u equal to image distance plus 1 upon object distance. Got it? So this is the relationship between these three values. So this is given by 1 upon f equal to 1 upon v plus 1 upon u. And this formula we have to remember. Easy formula or not? By this formula only we will be able to find out, for example, two values are given. So the third value we can find out with the help of this formula. One thing we have to remember, that the object is always on the left hand side, and if it is a real image, then also it is on the left hand side. If the image is virtual, it is on the right hand side. You remember this or not? Yeah, we will do some questions with us, Anvi. Don't worry. We will do the questions in the upcoming slides. Don't worry about this. So first of all, this is very easy formula. 1 upon f equal to 1 upon v plus 1 upon v. Okay, we will be practicing on it. Only one thing what we have to check, yes, Krisha, we have to remember is, this is the mirror, this is the principal axis, this is the pole. We all have to remember the sign dimensions. The object is always on the left hand side. We know this thing or not? Nisha, you know this? We remember this thing? Sanvi? The object is always on the left hand side. So the object distance is u. And when we are saying it is on the left hand side, it is always minus 1 point. Easy? because everything on the left hand side of the pole is taken as negative, numbered and numbered. Now one thing, this is the object distance. Object distance is always negative. So u values, whatever it is given 5 or 10, you have to say minus 5, minus 10 centimeters. Like now one thing, talking about the real image. If the image is real, it will be made always on this side only, right? If it is real image, it will be always on the left hand side toward downward direction. So this value of p, if it is real, it is always negative. If it is real, it is always the image distance I am talking about. This point is also clear or not? If the image is real, the position of the image would be where I have given this p. Okay? So this is the real image and it has to be on the left hand side, it has to be negative. Now one more third and the last point from my side, from our side, we all are a single team. Okay? If the image is virtual, where it could be made, the first case of concave we have to remember somewhere here. Right? Somewhere on the right hand side. Somewhere on the right hand side, like this. So that magnifying case, virtual, direct and magnified, the first case of that concave mirror. So this has to be the image distance. And in this case, the image is
गाइस आज ये वाला हम अब दूसरा मैच खेल रहे हैं
image distance and it is given by
पता नहीं कितना टाइम लगेगा
Now one thing is there, whenever we say the image is enlarged or magnified or diminished. Okay? If it is enlarged or diminished or magnified or diminished. So magnified means enlarged, bigger, and diminished means smaller. So there is one numerical value which we can take out with the help of the simple formula of magnification. The magnification, it is given by the alphabet M, small m. Okay? And the formula is h2 upon h1. So what is h2? Height of image. If we are comparing image height upon object height. So basically this is the comparison. For example, the image is double the size of object. You just remember, if image is double the size of object. So if object size is x, the image size is 2x. So what is m? So m is 2. Got it? If for example image height is x and image height is 2x and object height is x, then the magnification here would be 2 means twice. So with the help of this m formula, we will be taking out the magnification value. If it is less than 1, then it is basically diminished image. If it is greater than 1, it has to be bigger image. It can't be 0 because I am giving you an example for this. For example, h of O, height of object is 10 centimeter. Height of image hi, it is 20 centimeter. Then what is the magnification? So magnification is h2 by h1. So h2 is image height upon object height. Okay, h2 upon h1 image height. So image height is 20 centimeter and here the object height, it is basically 10 of centimeter. Okay, so one thing we have to remember, the centimeter and centimeter are the units beta. They will be cut off. Okay, and this is 2. So m is basically what we write plus 2. Okay, m value is plus 2. No unit. There will be no unit. Yeah, beta, it is very nice that formulas are coming in physics. You know, when we remember the formula, the numericals becomes easy. So formulas are good. Don't worry about the formulas. Don't worry. Now one thing. This was example 1. Okay, height of object is 10, height of image is 20, so magnification is plus. Now one more. Why there will be unit, no unit? Because with a centimeter in the numerator, centimeter in the denominator, they both will be factor centimeter and centimeter. For example, I am saying that the image is double the size of object. So it is double. So double don't need any unit. Getting my point? So that is where in magnification unit is not at all required. If I am saying this is a pen, I need one more pen half the size of this. So magnification is basically 1/2. Getting? One more example I am taking. Example 2. H O is equals to 50 centimeter. Okay? And HI is equals to 5 centimeter. So height of the object is 50 centimeter beta. And height of the image is only 5 centimeter. So what is the value of M? So HI upon HO, it is 5/50. So basically it is 1/10. So it is 1/10 or it is yes 0.1 also. No beta magnification can't be 0 because you know all the 6 cases of the concave, right? In every of the case, all the 6 cases, or you can say you can compare all the 6 cases, the magnification was bigger or smaller image, right? There is no condition that no image is formed. So that is why magnification can't be 0. Whenever it is of same size, so magnification has to be 1. I'm telling you how. You know when the object is placed at center of curvature, the image is also placed at center of curvature. Right, Arshit? So, for example, height of object is, it is 3 centimeter and height
What?
of image is minus 3 centimeter. You know Arshit, why I have written minus 3? You remember the sign conventions? The image height below, the principal axis has to be negative. You know, everyone? Yes? So M is equals to HI/HO.
किसी को हमारा बैटिया नहीं मिला.
Minus 3/3 equal to -1. So beta, when the M value is -1, what it suggests? You know, in the case of the object is placed at center of curvature, the image is also made at center of curvature, but object was above and the image was just below it in the inverse, real inverted and same size image. So real inverted, it means the magnification here it is minus. So whenever there is minus magnification, it means it is of real integer. Whenever there is the magnification of plus, it is a virtual image. And whenever it is value is greater than 1, it is magnified. Whenever it is less than 1, okay, then it is invisible. So I'll tell you how. First formula for magnification is this one. I am marking it as first formula. Image height upon object height. Basically, how much it is magnified? We have to compare the image height and object height. Then we will do the magnification. We can just compare. One more formula is there. If the height of the object and image is not given, only object distance and image distance is given. This is the formula where the object distance and the image distance V are given. Okay, that is minus V/2. So minus of image distance upon object distance. Like this. This is the another formula for magnification when the image height or object height are not.
देखो मैं कैसे लगा रहा हूँ.
Formulas for magnification. One is image height upon object height and one is relative This image distance of object distance into the minus sign. You know beta magnification has to be 1. Okay. Just tell me Arjit one thing. In case of the object is placed at center of curvature. Okay. I am giving your point in query so that I will not read it. Okay. Beta h2 means this image height. h1 means object height. Here you can represent by anything. Okay. Image height. It can be also represented by h
मर गया
as object height. h4. Now it's clear? And now what? Okay. You know this Arjit. When the object is placed at center of curvature, the image is also made at center of curvature. This is the case. Ray of light going like this. Okay. This was the diagram for the center of curvature. This is the diagram. So we know the object height and image height are in plus and minus. Getting? For example, the object height is, for example, 5 centimeter. The image height is minus 5 centimeter. So m value is 5 by 5, but it is minus. So it is minus 1. How can it be 0 beta? It can't be 0. Yes, I said mathematically it can't be 0. It can be minus. So this was the case, okay? And minus is for real. So these two formula you have to write 1 or 2 times, then you will be remembering it, okay? Then only you can. So 1 and 2, these formulas you have to remember. Now, whenever we are saying magnification value m, right? Two formula. Again I am repeating, again I am writing m has value of h2 by h1 and it can be minus v by u. So this is the total formula for magnification when both the cases in the signal box. Okay. Sir, I think I can't be zero because the object can't be right inside the middle. Yes, right beta. It has some distance. That is the thing. Okay. It can't be a zero size. Now one thing, magnification value, the sign of plus and minus, it denotes that the nature of the image which is made. If it is positive, it is virtual and erect. If it is negative, it is real and inverted. So if m is positive and if m is negative, if you are getting a negative value,
और यार हमारा 35 रेड का बैच बचा है,
I can write it like plus m
रेड का बैच बचा है,
minus m. Getting my point?
रेड को छोड़ना नहीं है
If m
किसी
is
में.
positive, then it is virtual and erect. If m value is negative, it is real and inverted.
टनाना
One more thing, mod
टनाना
m means magnitude,
टनाना
means how much bigger or smaller. Bigger
यार
or
हमारा का यार है.
smaller.
और यार मेरे पास टाइमिंग की क्या
This
होता है.
plus minus says is real or virtual. This plus and minus sign says it is real or virtual, and the magnitude of
पता
m,
नहीं
the
कैसे
value of m
यार
shows
पर
it is bigger or
मैं
smaller
बैठ गई यहाँ
whenever
तक.
we are comparing it to the
हम तो
one.
कम सेकंड
Okay,
था
one is the same size.
और इस बार
Because
जो
we have seen that if the object and the image are of same size, they will cut off
अब
5
इस
by
पर
5
हो जाए
equal to
यार.
1. So if it is less than 1, it is
No,
diminished image, and if it is equal to 1, it is same size.
अरे ये
and
राजा
when
जी
it is
आ
greater
गए.
than 1,
मुझे नहीं आता भी आप पेट बनाने.
okay, if it is greater than 1, then it is magnified image. So removing this
एक
dot,
ऊपर
dot, dot
वो
dashes.
नहीं है.
So this is the thing. When the m value is less than 1, it is diminished. If it is equal to 1, it is same size. And if it is greater than 1, it is magnified.
अगर
If it is
बनाने
minus
सकते
1,
हैं.
okay, if it is minus 1 means negative. So
Tamam.
1 that is negative means real and same size.
टनाना
I am giving one of the things. Example. M equal to minus 1. Okay? M equal to minus 1.
हाँ
Here is obvious subordinate, okay? Same size. Real and same size. M is equal to minus 2.
मैंने कब करा परेशान झूठती रहती है
And large means double the size. M value is plus 1. Virtual same size. If M value is plus 2.
हाँ रुको आ रहा हूँ
Virtual large means double the size. Now important, yeah, modulus of it means mod value means we are not taking only the minus and positive sign, the negative or the positive sign. Just we show the size. So this shows the size of the thing. Shows the size of the thing. Now I think these 4 examples are enough. M can't be 0. This is very much clear to us. It can be negative, it can be positive, or it can be 1. So that 1 is plus 2. Now one thing I would like to ask you. That case of dentist mirror. Okay, that case of
क्या